Today, I will present an Event Driven and Serverless architecture on Google Cloud from scratch, and I will show how it is simple to set up this kind of architecture in Google Cloud. Firstly, some words about me. My name is Mazloum Tosoun. I am a Google developer expert on Google Cloud. I am also the head of Data and Cloud at Group Biz. Group Biz is a freelancer group in France. I am also active in social network. I publish some contents. For example, I have a YouTube channel. I share my knowledge with videos on Google Cloud, data topic, DevOps, and so on. I write also some articles on Medium and GCP, and feel free to follow me if you're interested by my content. I am also a Paris Saint-Germain fan, but unfortunately, we lost the match today, but the life continues. I will present two use cases for this talk. The first use case, I will, for example, upload a file in GCS, then I will execute the event-driven architecture with Event Arc, and I will firstly use only Cloud Functions, and after this I will replace the Cloud Function by Cloud Run services. The serverless components are written in Python and Go, because with this kind of architecture I wanted to show how we can, for example, choose a different language if needed for any reason, and that's why I used Python and Go. After the first use case, I will present the same use case but with Cloud Workflows in addition. Workflows is interesting because it's a serverless orchestrator proposed in Google Cloud, and we will see how is it simple to have a more powerful way to deal with tasks with Cloud Workflows. What are the advantages for the event-driven architecture? Everything is driven by events, and we, for example, react to some modification in Google Cloud. For example, if we upload a file to GCS, we can trigger a component in real time. We can also react in real time for some ingestion in BigQuery and other elements. Also, an important thing, the components are decoupled, and it's easy, for example, every component can have is a standalone, and in this case there is no some coupling between components. In Google Cloud we have Event Arc. Event Arc make everything easy when we want to create an event-driven architecture. What are the cons for this kind of architecture? It is simple if we want to execute the tasks in sequence, but sometimes if we want to execute the task in parallel, it's not easy to do that natively with only with Cloud Function and Cloud Run services and Event Arc. That's why, in addition, we will show the architecture with workflow in bonus, because workflows is serverless, and it gives us a more powerful way to deal with the task orchestration. With workflows, we can, for example, execute the task in parallel and have many elements to orchestrate the tasks. What are the advantages of serverless components? For serverless, no infrastructure to manage. We can be directly focused on the business logic, and no need to care about or manage the infrastructure. Everything is given by Google Cloud, and we can be focused on the business logic. GCP offers all the needed components like Cloud Function, Cloud Run services, and Cloud Workflows, and we pay only when we treat the data and when we process the elements. If there is no element to treat, there is no cost, and that's why the serverless components are cost-effective. What are the cons for the serverless architecture? When we deploy some elements, we need to bring some optimization in the containers, because for example, Cloud Run scaled down to 0, and sometimes when we execute some requests, Cloud Run need to start very fastly, and we need to minimize start. And also, the serverless is not suitable to every use cases. Sometimes we need to have a cluster to respond to some need. I created a demo, and for the demo, I will show all the elements. I will zoom my screen. We have in this part the CI/CD part. The CI/CD part of this use case is done with Cloud Build. Cloud Build is also a serverless tool in Google Cloud. We will deploy all the Cloud Run services on the Cloud Function with Cloud Build manual jobs. Cloud Run depends on Docker, and we will publish the Docker image in artifact registry. In this use case, is this part, and the project is hosted in a GitHub repository. Is the first part of the use case. Then we have the application part. We will use the real data. It corresponds to the player statistic for the Qatar FIFA World Cup, and it corresponds to NDJSON file. When we will upload this file to cloud storage, we will trigger in real time the first serverless components. The event timeline is managed by Event Arc. We can see the event timeline at the bottom, and the first serverless component will transform raw data to domain data. Then we will write the result to cloud storage. After this, we will trigger a second serverless component that will add the FIFA ranking per team. For example, we have France have the first in the classement, and Brazil, and so on. And we will retrieve the FIFA ranking and set the elements in every team in our domain data. The result will be loaded and ingested in a BigQuery table. And at the end, we have a last load function, written in Go. This load function will move the process files to the input bucket, to a storage bucket called, it's a call bucket, only dedicated to storage. We have also, at the end of this use case, a Looker Studio dashboard. We will check all the calculate fields by the use case. Is finished for the architecture. I will show some code parts. Here you can see the raw data. For the raw data, it corresponds to the player statistic. The data are flattened. Then I will show the expected data. For the expected data, we will do a group by per team, and we will calculate the top scorer, best passer, and other business rules for this use case. We have two main folders, function and services. For functions, we have two important files. Requirement.txt, to be able to write a cloud function in Google Cloud, we need to have this convention. We have a requirement.txt file containing all the needed packages used by the cloud function, and we have the main.py file, and behind the scenes in Google Cloud we use function framework and also Cloud Event. With Cloud Event we can retrieve the bucket data here in real time. We upload the data in cloud storage, and we retrieve the data that correspond to the current event, and it corresponds to an upload on a bucket. We calculate the business rules and upload the results to a second bucket dedicated to domain data, and we finish to present the first load function. After this, I will show the script to deploy a cloud function in Google Cloud. We need to give the name. We have gen2 to indicate that it corresponds to generation 2, and we need to give the root folder containing all the logic of the cloud function, the entry point of the cloud function, the service account, and an important element, we need to give the filter with Event Arc. with the same command line, we will deploy the cloud function and also the trigger with Event Arc. And when we upload the file, we will react in real time. The filter here indicates that when we finalize to upload the element to this bucket, it will trigger this cloud function in real time. We have the deployment script cloud build here. Cloud build is serverless, it depends on Docker, and we have 3 bash scripts to deploy all the needed cloud functions. After this cloud function, the second cloud function. For the second cloud function, we have the FIFA ranking per team, and we will load the result to BigQuery. Here, there is an important thing in this code. When we use the BigQuery Python client, I recommend to use a try-catch in the code, because natively we don't have access to the error occurred in BigQuery. Because BigQuery indicates we need to access to the error collections, and natively we can't access to these error collections. And if we add a try-catch block, we can have access to the error collection with this exception, client error. I showed the script for the last cloud function written in Go. We have the same principle here. We have the source and entry point. And to react to BigQuery, there is no native filter with Event Arc to react in real time, like for the GCS. We need to use audit log in this case, because every action in BigQuery behind the scenes is written by audit log. That's why here I used the audit log written and the insert job. And I think it's good. I show the logic of the cloud function. We use audit log entry, and I also show you the contract for audit log. We have this standard payload for audit log, and audit log will give us the current table concerned by the ingestion and also the current data set, and if there is at least one ingestion in the table. In the Go code, we will use the entry audit log object and add a check if it corresponds to the expected table, and also if there is at least one ingestion in the table. And if it's the case, we will move the process files to the storage bucket. For the Cloud Run services, we need to build the Docker image and publish them to artifact registry, and then we have a script to deploy the Cloud Run services in Google Cloud. For the script, the principle is the same. We have the convention to write Cloud Run services is to use a main.py file. In my example, I used Fast API instead of Flask. In all the Google Cloud official documentation use Flask, but in my example, I wanted to use Fast API instead, because Fast API proposes more support for asynchronous call and also a Swagger natively. We can react with this object Fast API. We can retrieve the data correspond to the bucket and write the result to a second bucket. I show after the command line for the Cloud Run service. The command line here, we have two commands. One to deploy the Cloud Run service based on the Docker image, and a second command line to create the trigger with the Event Arc filter. The same principle for the cloud function, but with two command lines instead of one. We need to write also a Docker file. For the Docker file, we copy the requirement.txt file in the container, and after this, we will install all the Python packages in the container, and we will use uvcorn to serve the Python application. We will show the last Cloud Run service with audit log. We have two command lines with the audit log filter, and I think it's good. And at the end, we have the same kind of logic, but in this case, instead of Go, I used Python for the Cloud Run service for the last serverless components, and move the process files to a storage bucket. I will trigger the use case in real time. I have a script to copy the element in the input bucket and trigger the architecture in real time. This script will copy the file in the input bucket. I then access to BigQuery, we have the result to BigQuery. In this page, we have all the cloud functions, and we can access to the log for each cloud function here in Google Cloud. And I will then execute the same use case for Cloud Run services. I think it's good. We have this page containing all the Cloud Run services, and we can access to the log for each service. I show after the second use case. For the second use case, I had a workflow in addition, and the workflow is deployed with Terraform. For the use case with workflow, we copy the element in GCS. The event arc will trigger the workflow in real time. We have two workflows, one with Cloud Function and the other with Cloud Run services. In this case, the component was deployed with HTTP calls instead of a Cloud Event. And in this case, we have a more powerful way to deal with tasks and orchestrate the task with workflow at the middle of the architecture. As I explained previously, the CI/CD part is done with Terraform in this case. Terraform will create the workflow and also the trigger. Workflow is based on YAML and API calls. And we have the first cloud function here, an HTTP post. We give the URL of the cloud function, and we use OIDC, secure authentication in this case. We have the same principle with the Cloud Run service. It's easy to orchestrate the task. And for Terraform, we have two resources. One, to create the workflow. We need to retrieve the source content as a string with Terraform, with the file operator. And we have also the trigger. We create the trigger with the event arc filter. We have the same approach with the Cloud Run services. We will trigger the workflow and the second use case in real time. I upload the file, and then I will show this page in Google Cloud contains all the workflow. And here in this page, we access to the tag of the workflow. We have access to all the steps of the workflow and access to the input and the output of the workflow. At the end of this use case, I show all the calculated fields in the Looker Studio dashboard. We have the total average goal per team. We have the best passer, Kylian Mbappé and Lionel Messi for the FIFA Qatar World Cup. We have the best passer, the most top runs. We have the most successful tackles, the goalkeepers, and so on. I will finish with the slide. A little comparison between Cloud Function and Cloud Run. If we want more managed service, it's interesting to choose Cloud Function instead of Cloud Run, because we only need to write the code and everything is provided by Google Cloud with the serverless approach. But if we want more flexibility with in order to have proper runtime on several web servers, for example, Cloud Run is more interesting because it offers more flexibility. We can install everything in a Docker container, and it's interesting to have this flexibility sometimes. In a conclusion, I presented a real-world use case with the FIFA Qatar World Cup player statistic data. We saw a full event-driven architecture with GCP, and interesting for the latency. And we saw that how it is simple to set up this architecture in GCP, with Cloud Function, Cloud Run services, and workflows. And this architecture allows us to choose the needed languages if needed. The project are hosted in my GitHub account. I share the two repositories, and we will share with you all this code, all this architecture, and we can clone the repository, work with this, and play with this, and feel free to contact me if you have some issue. Thank you so much. If you have some question, don't hesitate to ask me, and it was a pleasure for me to be here with you and to share this concrete and complete example with you.